welcome back to Elementary Algebra. I'm your instructor, Amy Flicksteiner, and we are going to take a look at dividing polynomials today. Ooh, I've gone dark. What's up with that? Okay, we're going to take a look at dividing polynomials today, which means long division. So, to recap your long division skills, right? Where are they? How are your long division skills? You ready for this? So, long division from grade school is essentially what we're going to be using. Basically, if you had to take, let's say, 165 and divide it by, I don't know, let's do 13. How would you do this long division problem? No calculator, long division, right? I'm not saying you don't get a calculator. I'm saying we need to remember the algorithm here. So the idea here is that when you go to do this problem, you would take 165 and you would divide it by 13. And you would do 13 goes into 16 one time. You would multiply that back. And then you would subtract the 13 from 165, giving you a 35. You would then go 13 goes into 35 2 times, or as many times as you could. 13 times 3 is 39, so it won't work. It needs to be 2. Then multiply back. 2 times 13 is 26, and subtract that. 35 minus 26 is 9. And initially, before we knew about fractions, your answer would have been 12 remainder 9. Once we knew about fractions, it would have been 12 and 9 over 13, or 12 and 9/13. We're going to be building upon this idea of division, well, this idea of fractions and fractional parts, as we do long division with polynomials. Let me show you what I mean. It's the same algorithm, just with letters now, because, it's algebra. Okay, so we're going to simplify this using long division. We're going to take x squared minus 6x minus 8, and we're going to divide it by x minus 8. So this, just like the 165, x squared minus 6x minus 16, and we are going to divide that polynomial by x minus 8. Okay? All right, here we go. So, x goes into x squared. If I take x squared and I divide it by x, I am left with an x. X goes into x squared x times. Now, just like here, I'm going to multiply back. X times x is x squared. X times a negative 8 is a negative 8. Now the problem is, negative 8x, sorry. Now the problem is I need to subtract. When you subtract, when we did the vertical a couple of sections ago, right, we're going to call back on that. Subtraction is the same as adding the opposites. So we want to think of it as subtraction, but we are adding opposites. So I have x squared minus x squared, which is 0x squared. And I have a 6x plus 8x, negative 6x plus 8x, which is 2x. And then I'm going to bring down that minus 16. Right? Just like we did up here, we brought down that 5. Same idea. My pens. All right. Now, x goes into 2x 2 times. 2x divided by x would be a 2. It would be a positive 2. Once I know what that is, then I will multiply back. X, or 2 times x is 2x. 2 times a negative 8 is a minus 16. I want to subtract that entire row, which is the same as adding the opposite of each term. I I'm using multiple colors to keep my steps straight. Now I have 2x minus 2x, which is 0, and negative 16 plus 16, which is 0. So if I were to divide x squared minus 6x minus 16 by this x minus 8, the result is x plus 2. The clincher here is that you can check it. To check it, we would take that x minus 8 and we would multiply it by x plus 2. The first gets me x squared, the outside gets me 2x, the inside gets me a minus 8x, and the last gets me a minus 16. When I combine my like terms, I have 2x minus 8x, so I have x squared minus 6x minus 16, which is exactly what was inside what I was dividing by. So to check, we multiply back. Right? Okay. Sometimes you will see the division this way in fraction form. It's simply a different way of writing this same thing. We are going to take the x squared plus 7x plus 12 and divide it by x plus 3. So the x squared plus 7x plus 12 will go underneath the grand division bar. The x plus 3 will go on the outside as our divisor. Okay? So what we're going to do is x squared divided by x is x. Multiply back. X times x is x squared. X times 3 is a plus 3x. Draw that line. Subtract, which is the same as adding opposites. That's going to give us 0 here and 4x. Then we're going to bring down that plus 12. 4x divided by x is a 4, a positive 4, so I'll do plus 4. Then I'll multiply back. 4 times x is 4x. 4 times 3 is 12. Subtract. Subtraction is the same as adding opposites or distributing that negative. 4x minus 4x is 0. 12 plus a negative 12 is 0. So if I take x squared plus 7x plus 12 and divide it by x plus 3, I do indeed get an x plus 4. To check, I can multiply back. So I have x plus 3 times x plus 4. That's going to give me an x squared. Last is 4x. Inside is 3x. I'm sorry, outside is 4x. Inside is 3x. Last is 12, or x squared plus 7x plus 12, which is indeed what was underneath. So I know that that answer is correct. All right, nice. What's next, Amy? A couple more problems with just a little bit more difficulty on them. I have a 6m squared minus 7m minus 5. And I'm dividing that by a 2m plus 1. So 6m squared divided by 2m. Or, if you'd rather, 2 times what gets you 6. M times what gets you m squared. So m times m gives you m squared. Now I'm going to multiply back. 3m times 2m is 6m squared. 3m times 1 is 3m, and it would be positive. I'm going to subtract this, which is the same as adding opposites. That gets me, those will cancel, and I'll have a negative 10m minus 5, because remember, we bring that last one down. 2m goes into a negative 10m minus 5 times. Multiplying back, I have a negative 10m. Negative 5 times 2m is 10m. Negative 5 times 1 is a negative 5. Now I want to subtract, which is the same as adding the opposites. So I zero out, and I get an answer of 3m minus 5. This is one where I would probably check. I might not check on some of the other ones, but when I have coefficients like this, I do usually check 3m minus 5. So that's a 6m squared. Outside would be a minus 10m. Inside would be a plus 3m. Last would be a minus 5. So 6m squared minus 7m minus 5. Okay, yep. So I know that one's right. Okay, 4 is the same thing again. We're just going in a little bit different form. We're using that divide one by the other. So I'd have a 3g squared minus 13g plus 12 divided by g minus 3. G, notice how I'm entirely ignoring the second term because we can work on that. G goes into 3g squared. I need a 3g up there. Multiply back, I get a 3g squared minus 9g. Subtract, which is the same as adding opposites. So that's no g squareds minus 4g. Got another point there, so I'm going to bring down the plus 12. G minus 4g, so I need a minus 4 to make that. That's going to give me a minus 4g plus 12, which I will need to subtract. That's the same as adding opposites, which is going to zero out again, and I end up with a 3g minus 4. If I'm not sure, I will check by doing g minus 3, 3g minus 4, or 3g squared for the first. The outside would be a minus 4g. The inside is a minus 9g, and the last is a plus 12, or 3g squared minus 13g plus 12. That's what I had under there. So, yep, this one works too. All right. Okay, next step. What if we have a remainder? So these next couple of examples are going to have a remainders. So when you see q plus r over d form, that means that you will have a regular looking polynomial and then you will have a remainder hanging on. And that remainder needs to go over the divisor. Okay, what does this look like? If we have x squared plus 7x plus 14, and we're going to divide that by x plus 4. Okay, this is the divisor. And then this is the dividend. So that goes underneath the division symbol, the big old division box. X times what gives you x squared? That's an x. Now I'm going to multiply back. X times x is x squared. X times 4 is 4x. It's positive. I need to subtract those, which is the same as adding the opposites. The x squared minus x squared will zero out. 7x minus 4x is 3x. And this 14 comes down. Okay. Now, x times what gets me 3x? Well, that needs to be a plus 3. I'm only concentrating on that first term. Then 3 times x is 3x. 3 times 4 is 12. I need to subtract this, which is the same as adding the opposite. So 3x minus 3x zeroes out. 14 minus 12 is 2. That did not zero out. This is my remainder. When dealing with polynomials, it is quite simple to do, but it's awkward. Like it feels wrong, but it's not. So my answer here is the x plus 3 with a remainder of 2. The way that we write this is x plus 3 plus 2 over x plus 4. The remainder over the divisor from here. Okay, so that's where that's coming from. This should be my answer. Can it be checked? Absolutely. I need a Post-it because I need a little bit extra here. All right, so if I'm going to check this, this one takes a little longer. I'm going to take this, I'm going to take that x plus 4, and I'm going to multiply it by x plus 3 plus 2 over x plus 4. Right? So that's going to give me x. I'm going to do x plus 4 times that x. Then I'm going to do 3 times that x plus 4. And then I'm going to do 2 over x plus 4 times that x plus 4. X squared plus 4x plus 3x plus 12 plus, do you see how the x plus 4 and the x plus 4 here, these will cancel?